Hello everyone and welcome back to the channel. This week we're kicking off a series about SQL injection, but instead of jumping straight into the vulnerabilities and the exploits, I wanted to give a primer about SQL itself. I think that so many pen testers and hackers have a really good understanding of SQL injection. They understand the incantations on how to spark an injection, but they don't necessarily know how to work with SQL on the back end. And I think that's a skill that you really need to have to truly be able to master SQL injection and get really good at it. So let's dive in. For this series of videos, I've created a Git repo that contains a series of helper scripts and web applications and other demo tools to be able to fully explore SQL and SQL injection. I'll put a link for that in the description below. I'll be adding to this repository over time as I develop these videos. So if you're watching this sometime after release and your repository looks slightly different than this video does, not to worry, everything will be fine. For this video, we're going to need a running version of some sort of SQL server, and I'm going to primarily be using MySQL or MariaDB. There is a Docker config file located in the Docker directory if you would like it. Also, you can set up your own instance however you prefer. If you need help setting up your own instance, or you don't necessarily know how to use the Docker file inside this directory, I have another video that you can check out on the right side of the screen, and I'm also including a link down in the video description. The environment I'm using is the one coming from the Docker example in the installing SQL video. So if you're new to this and you want to follow along exactly with what I'm doing so that it's harder to get lost and it's easier to follow along, that's what I'd recommend setting up for now. Aside from web applications, the primary way that you're going to interact with databases is through the database client. In this case, we're using a MySQL-based database, so we'll be using the MySQL client. If you don't already have it, if you're running on Debian or Ubuntu, you can install it with apt. So apt install default MySQL client is the way you're going to install it. I already have it, and if you followed along with the other video, the installation video, then you will already have it as well. But just in case, if you're not on a Debian or Ubuntu, you can look up how to download it. It's going to be pretty simple to find. The syntax that we're going to use pretty commonly is we'll use the command itself. And then since we're connecting to a database that is somewhere, it's not on the local host. In this case, it's in a Docker container. We're going to say that we need to connect to it remotely. In this case, we are connecting to it through localhost, but it's not a service on our host. We have to connect to it over the network, not a local file system socket. Then we'll use -u to specify the user, and then we'll use -p to say that we want to enter a password. We're not putting a password into the command line. We are simply saying, hey, I want you to prompt me for a password. So there's the prompt, we'll enter our password, and now we're in the database. Over the next couple of commands, you're going to see some data in the database. If you're following along, you're not going to see that in your database. Don't worry about that. I've pre-populated my database. I'll show you how to populate your database with data after this next couple examples. When interacting with databases, it's important to understand the structure of the databases itself. This starts with even understanding the word database. When somebody says that database over there, they can actually be referring to multiple different things. At the highest level, it could be referring to the actual hardware or cloud instance where the operating system that houses the database is running. It could even be a cluster of those servers because most database software supports clustering. So it could refer to the host itself. It could refer to the service that is running on the operating system. So for instance, the MariaDB or the MySQL service that's running, or it could refer to an actual database inside of the database service. You can actually see what databases are available from within the client by using show databases. And here we can see that there are multiple databases within this database server. The one we're concerned with for this series is the T-WebApp database, and that's the test database that I set up to use as examples throughout this series. To be able to use the database, we're just going to use the use command. So we're going to use T-WebApp. And now you can see that the targeted database is updated, and we can see that we're using the T-WebApp database. To help demonstrate the structure, I'm going to throw out a couple database commands real quick. Don't worry about understanding these. We're going to go over them later in this video. We're going to select star from directory. This demonstrates the layout of a database. Within a database, there are a number of tables, and a table you can almost think of like a spreadsheet if that helps the visualization. But you can see the representation of a table on the screen right now. There's a series of columns or fields, and each row is a record in the database. It's important to understand that every column needs to have a value in it. So even if that value is null, then there will still be a value there. Now, how did we populate that data? There's something called SQL scripts, and like most scripts, they can seem overwhelming and daunting if you look at them and don't really know what you're looking at. But if you think of them as just one command per line, it makes it much less overwhelming. So there was a SQL script included in the Git repository that I linked. If we take a look at start.sql, we can get an idea of what SQL scripts look like. As with most scripting languages, there are ways to create comments in SQL, and these comment characters work inside of SQL statements as well as inside of scripts. There is no difference between what works in scripts and what works in the command line or web applications. So the first example of a comment character is this multi-line comment character. You start it with a /* and end it with an */. Anything between those two things is a comment. And here I just say what the script is, how to access it, and how to use it to get information in the database. We'll be using these commands a little bit later to get your data going. Another example of a comment character in MySQL is --. And with MySQL specifically, you need to have a space behind the double dash for SQL to recognize that that is a comment character. Other databases recognize comment characters differently, and as you explore that, you can look that up as you go along. The early part of the script is just clearing out any of the test data. A lot of times I create scripts like this for CTFs or for labs. That way, if you're experimenting and mess something up beyond recovery, you can just rerun the script and get to a known good state. So that's what these first couple of lines are doing. The first line that we really want to concern ourselves with is the creation of the database itself. And that's creating the T web app database, the test web app database. After that, we're going to use that database so that we can target that database for the commands that come later. Now we're going to create users. The syntax is pretty straightforward. We're going to create user. Web admin is going to be the username, and the % here is just saying that we want this user to be able to log in from anywhere. What can often go in that field is either localhost, if you only want them to be able to log in from 127.0.0.1. You can put in IP addresses, host names, etc. This is just saying can log in from anywhere. Identified by, and then we're putting a password here. There are other directives that allow us to put in password hashes or assign external authentication services and things like that. If you actually want to dive deeper into database administration, I fully encourage you to do that. That's kind of out of the scope of this video. So we're doing things relatively easy way just to get things moving. So here we're putting in a very insecure password in plain text into the script. The next line is to grant privileges to that web admin user. We're going to grant all privileges on this specific database, all tables is how you read this. We're going to create a user level user, a non-admin user as well. And we're going to create web user. This time we're leaving off the @%. If you don't specify a host to log in from, then it just assumes it can log in from anywhere. Identified by their password. This time we're not going to grant all privileges. We're only going to grant the select statement. This is a really good way to lock down what different users can do in your databases so that you're not allowing admin level privileges for any user. Now that we've got our users created and the permissions set for that, we're going to create our tables. Here's a few examples of what table creation looks like. The first thing we're doing is we're creating an ID field. And this is just going to be used for a unique identifier in case we have users that have similar names or similar email addresses. We can tell different records apart. The first entry in this is going to be the name of the column and then the data type. The number inside of the parentheses is going to be the length of the field, integers are always going to be 4 bytes. What the length number is telling you for integers is how many characters there should be for padding purposes. We want it to 0 fill, so it's 0, 1, 0, 2, 0, 3, 0, 4, instead of just being 1, 2, 3, 4, etc. We don't want it to be null, so when a record is created, it will fill in an ID if one's not provided, and it's going to auto increment. The last ID used was 2, the next ID will be 3, and it's going to be a primary key. Primary keys are used by SQL databases to identify unique records. So even if you have multiple rows with the same username, same email address, the primary key will differentiate them for you. This is a very deep subject that you can talk to DBAs about endlessly, but that again is out of the scope of this video. The next column is fname for first name, and we're using varchar as the data type, which is just a character or string data type, and it can be up to 32 characters long. Lname up to 64 characters long, email address up to 128 characters long, affiliation can be up to 32 characters long, and then we have an active column, which is a Boolean, so either true or false. These two tables are just more of the same. And here we're inserting some test data into the database. This will be your first look into one of the more common queries. We'll go over insert a little bit more later, but the gist of it is that we're going to insert into, and this is a table name, so we're inserting into the directory table. We give it a list within parentheses of the columns that we're going to insert data into. The values keyword tells the database what follows is going to be the values. These two lists, the list of columns and the list of values, need to be the same length, and the data types of the values need to match the data types of the columns specified, and they're in order. So this is fname, this is lname, this is email, this is affiliation, this is active. You can't jumble these up. You will get database errors. Now that we have an idea of what's inside the script, we can quit out of this. We're going to use the commands that you saw at the top of the SQL script to get that data into the database. If you're following along with me and using the Docker method from the previous video, we set that Docker container to randomize the root password at creation. So we need to check out what that root password is. So we're going to use a Docker command, docker logs MySQL. So we're using the Docker command to check the logs of the MySQL container. We're going to redirect the standard error into the standard out. We want them in standard out because we're going to pipe to grep, and we're going to case insensitively look for password. So for me, the password that was generated when the container ran is this. Then I'm going to use the MySQL client to connect to 127001 with the user root, and we're going to ask it to prompt us for a password. We're going to direct start.sql into that command. So instead of going into interactive mode or supplying a command, we're going to direct that script into the MySQL client. It'll ask us for a password. We shift control V to paste what we just copied in, and we don't get any errors back. That's good. If there are errors, we'll see them. If there is no feedback, then the script worked just fine. Now that we've got our test data into the database, we can start connecting to the database with our MySQL client, and we can start going over some of the more common queries. So we're going to connect to 127001. This time we're going to connect as user admin and ask for a prompt. We type in the password we set, and we're now connected to the database again. Now that you have your data in, you can use tweb-app. We're now targeting the test web application database, and we're going to review the insert query now. You saw the insert query in the SQL script. We're going to try something else. So if we do insert into, and the table name is directory for this, instead of supplying all of the rows, we're only going to supply a couple of the rows just to see what happens when we do that. So we're going to do fname, lname only, and set values to, and I'll use my name. You can use your name if you want. You can use my name if you want. You can use any name you want. Something that you may have noticed in the script that I didn't explicitly point out is that all SQL commands end in a semicolon. That's how the database knows that you're done inputting a command and it's time to process it. If you leave it off inside of the client, it's okay. It just assumes you're doing a multi-line command, and you can just put in the semicolon and hit enter. I forget all the time. We didn't get an error back. It said that one row was affected, meaning that it added a row because that's what we asked it to do, insert. That's great. Now, how do we see what it did? It's time for our second query type. You saw it earlier. You've probably seen it in the wild before, but we're going to learn about select. So we're going to select star from directory. So the way this query is set up is that we select, and this will be a list of column names from whatever table we're trying to query. So we could do, if we wanted to, like select fname, lname, email, affiliation, and active if we wanted to do all of that. But we want to type as little as possible, and we do want to see all of the fields, so we can just do star or asterisk to select all of the columns. And here we can see that all of the test data that you saw before is there, but now we have a row for me, and the fields that I didn't put in manually say null. Earlier, when I was telling you about the structure of the database, I said that all columns had to have a value. Fine, but we don't necessarily need to insert values to every single column. The database will make up for that. The ID field, since that column was set up as not null, automatically enters a number for that column. Everything else just puts in null if it's not supplied. When we're doing a select statement, what the database is doing, not literally, but effectively, is going row by row and then printing it out for you. If we want to be a little more discerning about what data is being printed out, we can use something called where to set up a conditional statement for our select. So if we select star from directory, but we wanted to only return records where the affiliation is the Rocinante, we could say where affiliation equals Rocinante. Again, we have to finish it with the semicolon. And if we hit enter now, we only see the rows where the affiliation is with the Rocinante. We can make other queries based on other columns as well. So if we wanted to say where active equals 0, so they're no longer active with that particular organization, we only get the inactive records from the directory. If we wanted to do something instead of equals, and we wanted to say everything that is lower than, we can use the less than operator. The only number we really have available to us right now is the ID. So we can say ID is lower than 5. And we just see the records 1, 2, 3, 4. Or we can do the greater than 5. And we see the higher records. If we want to do less literal matching and we want to do fuzzy matching, we can use the operator like. So for instance, we can select star from directory where email, and we want to get all of the emails for the Roci. So we'll say email like, and we use the % as our wildcard. And again, the % just means any character, any number of times. It's almost like an asterisk in other applications and operating systems. %@rossi.net. And now we only get records where the email address is for the Rocinante. We can do things not. So if we wanted to get all records where the email wasn't the Rocinante, we can say email not like. There are also and or operators. So we can say we want to select star from directory, and we want to know all of the UN affiliated folks, and that could be either the UN or the UN Navy. So we can say from directory where affiliation equals UN or affiliation equals UNN. And we can see all of the UN affiliated folk. We can also use the and conditional. Instead of one or the other of the conditions to be true, both or all conditions have to be true. So we can say something like select star from directory where affiliation like %UN% and active equals true. And this will give us all of the affiliations that have UN in it. So the UN and the UNN, but only the active people. And obviously that's just Christian. We can combine and or if we want, using parentheses to make complex logic. So we can do something like select star from directory where active equals true and affiliation equals UNN or affiliation equals MCRN. So we want only active members of military organizations. Now that query came back empty, so we wonder why. We can flip this to false and see the retired members of different military organizations. And we see that the only people in our directory that have served in some form of solar system military are no longer active in those organizations. But it gives us an example of how we can chain and ors and nest things inside of parentheses if we want to create complex logic. The last bit of conditionals that we'll cover for where before we move on is the not statement. So we can do something like select star from directory where email not like, and we can see all of the records that are not from the ROSI. If we want to use not with literal matching instead of fuzzy matching, we use the exclamation point. So if we wanted to do something like select star from directory where email like ROSI and fname is not equal to Amos. Sorry, Amos. We'll see all of the Rocinante records except for Amos. The next query type we'll go over is the update query, and it is used to update values of records. The way it works is we type update and the table name. So we'll update some values in the directory table. Set, and then we do a column equals value, and we can do a whole list of those if we want. This time we're just going to set one, so we'll set the active column to true. And while the update query does not require a where clause, if you do not specify a where clause, then all rows will update this column's value to the new value. You almost never want to do that. So we want to do a where. While the update query does not require a where clause, in my opinion, it requires a where clause. So we'll say where, and for this scenario, we're going to say that the MCRN is recalling all of their retired assets and reactivating them. So we'll say where email like MCRN and semicolon. So we see that 2 rows matched and 2 rows were changed. And if we do a select star from directory again, we can see that now the MCRN, Bobby and Alex, who used to be in the MCRN, are no longer. They are now active again. And that's basically the update query. Moving along to the delete query, all it does is delete rows from a table. So we say delete from and then the table name. So directory where, and I'm going to get rid of the record of me because it doesn't belong there. I'm not on theme in any way, and I don't have most of the information filled out. So I'm going to say where fname equals Derek. And we can see that 1 row was affected. And if we do a select star from directory, we can see that my record is no longer there. Anytime you're changing data in the database, you want to be very careful. And this is why in the SQL script, we created a user that could only run select statements, because this kind of operation can be very dangerous if you don't know what you're doing or you mistype. The last query type that we're going to go over, and probably the most important and powerful query type that you'll use as you go on your SQL injection journey, is a union select. So the way this works is that we write a normal select statement. So we'll say select fname, lname from directory. And this will just show every row, but only the fname and lname columns. What we can do is a union select. So the same query, but then we say union select at the end of it. And what this is for doing multiple queries and having them output at the same time. So the way this works is you just add another select statement. So we can say username, password from the users table. And we now see that we've got the original list of the fname, lname, and then we also see the usernames and passwords from the users table. What's important to know about union select is that the number of columns has to match. If the first select was fname, lname, email, and we ran this, we would get an error because they have different number of columns. What's also fun about union selects is that we can have multiple where statements. So this first select can have a where statement where email like Rossi, and it will only return the Rocinante users. And then the second union select can also have its own where statement, where username equals a Kamal. And so here we got the list of fname, lname, and we only got the one username and password. Understanding the nuances of union select will go a long way in helping you perform better SQL injection attacks. The last concepts to cover in the SQL for Hackers video are query modifiers. And the two probably most important ones that I can think of are the order by and limit. So if we wanted to do a normal select statement where we select star from directory, we see that we get 9 different records returned. We can order them by different things. So for instance, we can order by fname. And now the IDs are no longer in order, but we have an alphabetical sort for the first name. That doesn't change the layout of the table, that only changed how it was presented to us. The other is limit, which limits the number of returns that we can get. So instead of sorting the returns, it just limits the number. So we'll do our normal select statement again, select star from directory. And this time we'll say limit 3. And so we just get the first 3 responses. Now you can chain order by and limit. So we can do something like order by fname. And what it'll do is sort by first name and then only give us the first 3 responses. I'm glad you made it to the end of this video. Hopefully you learned something and found it useful. Our next video is going to be an introduction to SQL injection, where we actually attack a basic web app and do some basic logic injection and SQL injection. I hope to see you there.